Bonjour, baddies. Welcome back to another video. Today's first question is, let x and y be two positive numbers such that... Okay, I'm not writing that. Express the square root of x divided by the square root of y as a fraction. So if we write this out, since it's asking for the square root of x over the square root of y, we can sort of just push the equation in that direction by making a couple modifications, such as we can multiply both sides by a 41 to get rid of the 41 under the y. So if we do that, you're basically going to get, write that out real quick. It should look like that on the numerator. Is equivalent to y is on the bottom now. And if we wanted to isolate x by itself as well, we can divide both sides by 13. So such that 1/4 square plus 1/5 square. So your equation should probably look something like this. And now, since we're trying to push the equation towards the square root of x divided by the square root of y, we can square root both sides. So we can get something like this. So this is sort of just a clear path now. So let's continue. When this is equivalent, so basically now we just start solving. 1/2 square is 1/4. So 1/4 plus 1/9 over, forget the square root, 13, 1/16 plus 1/25. And you know that this side is literally just the square root of x over y now. So we know what our sum is, what our product will be. So we just continue in that direction. So now that we have this, we just basically start solving, make the denominator the same, yada, yada, yada. So 36, top would be 13, bottom 400, the top 41. So if I write this out in a more neat manner, it should look something like this. And now that we know this far, we can start simplifying. So the 41 and the 41, the 13 and the 13, and even the 36s can go down together. So 9 and, we'll call it, divided by 4, so 100. So now we have a 1/9 over a 1/100th, which is basically 1/9 times 100, which is 100. This is equivalent to 100 over 9. And then when we bring it out of the radical, we will get a 10 over 3. And so 10 over 3 is our final answer. Moving on to problem number 2, determine the values of x for which the expression this is not defined. So basically, there are two circumstances under which this expression would be undefined. Either the inside of the radical is negative, or the bottom, aka the denominator, is equal to 0. Because if you've never learned this in school, the denominators are never allowed to be 0. So taking that into careful consideration, we can write an equation pretty much similar to this. So x minus 1 less than 0, or x minus 1 is equivalent to 0. So now that we have this, we can basically start solving for the two cases. If x plus 1 over x minus 1 is to be negative, that means that one of these above are equivalent to being negative. So basically, there are two circumstances under this would happen as well. X plus 1 is less than 0, and x minus 1 is greater than 0, or under circumstance 2, x plus 1 is greater than 0, and x minus 1 is less than 0. So we can solve for both to basically see which one would actually work. Because there are some circumstances which basically just don't fit. And you'll see what I'm talking about very, very soon. So looking at this equation, if x plus 1 is less than 0, that means that x has to be less than negative 1 because you move the 1 to the other side. Or, under the second circumstance, that means that x has to be greater than 1. But this doesn't make any sense because a number cannot be less than negative 1 and greater than 1 at the same time. So, circumstance 1 is a flop. So, we can look at circumstance 2 now. Circumstance 2 states that if x plus 1 is greater than 0, so x has to be greater than negative 1, and x minus 1 is less than 0, so x then has to be less than 1. And this works because a number can be greater than negative 1 and less than 1 at the same time. So we are going to use circumstance 2 because circumstance 1 does not work and makes no sense. So now that we've gotten this part sorted out, we can start looking at this part. The or, x minus 1 is equivalent to 0. So this one is pretty simple. You just move the 1 to the other side. So x when it is equivalent to 1, it also is undefined. So now that we have this, we can write out sort of like something that if it fits these standards, then it is undefined. Keeping x, we have, since it has to be greater than negative 1, but greater than negative 1, it cannot equal or be greater than 1. So less than or equal to 1. This is when x is not defined. These are the things they basically have to meet. So yeah, that is the end of this video. I hope you guys enjoyed, and I hope you guys learned something new. And I will see you guys in the next one. Bye-bye.